Hey there, welcome back to the channel. Today we got another 4L60E autopsy for you, and this one is under most unfortunate circumstances because this is a comeback. In other words, I had rebuilt this transmission just a short while ago, and after only 200 miles on the road, it lost third gear. So I'll start off by saying that, and it's okay if you don't believe me, but I very rarely have comebacks for any reason, and in the case of 4L60E 700R4s, almost never with the 3.4s. In the case of the 700R4, I've had a few come back because the TV cable was not set up or adjusted correctly, and as a result, the clutch pack burned up. But the only other situations where I've had 3.4 failures shortly after rebuild were because of a latent defect in the drum, which is a possibility here. And in that particular scenario, transmission was on the road for about 500 miles or so, and then driver noticed that there was like some flaring on the 2.3, and then very shortly thereafter he lost third gear altogether. It was just neutral. And when we took that transmission apart, we noticed a lot of cracks in the crown of the drum, and that's why I always tell you to scrutinize that area. It is a source of potential problems because some people like to take the shafts out for whatever reason. Maybe the splines are worn, or maybe they need to adapt it to fit another application, and they'll beat the shaft back in, or the replacement shaft in, instead of installing it on a press, and that'll stress that area and cause fractures internally, which may or may not be visible. In a couple other circumstances, one was my fault. Way back when I first started doing this, I cut a lip seal on the third clutch piston of 700R4. After I did that, I stopped using those stupid aluminum pistons altogether, although it was still my fault. I mean, it wasn't the fault of anything else. It was just, assembler error. And then there's a couple other circumstances where we had some gear train failure due to lubrication restrictions that caused some of the hard parts to fail catastrophically. Metal migrated to the area of the sealing rings and cut them, causing 3.4 failure prior to the transmission failing due to degradation of the gear train. So anyway, we're going to take this thing apart, see what's happened, see what's going on with it. Give the backstory first. Transmission was on the road for about 200 miles, shifted perfectly fine until on or about that 200 mile mark. Driver noticed a very slight flare on the 2.3 shift. He continued to drive it, had to get where he was going, and on the way back he noticed it again. Happened a few more times, and then he lost third gear altogether. So the next day he dropped the pan just to see what may have happened, to try to investigate and see if there's anything he could have done to repair the condition. I mean, he's not a transmission builder, so he doesn't know that that's not really possible. When you have this kind of failure, you can't really fix it from just dropping the pan. But he did check his solenoids. He checked the make sure the harness was connected, and just kind of doing some due diligence to figure out what went wrong. He said that the fluid looked unremarkable. In other words, it looked brand new. There was no burnt clutch material in the pan, no metal, nothing like that. It was just simply, kind of a mystery to him. I mean, the filter was as expected. It wasn't clogged with anything. So anyway, he put the pan back on, filled it back up, and then tried to drive it again. And it just went from, a slight flare to a neutral condition, and he lost all third and fourth gear. So anyway, told him to bring it back. Something clearly happened, and we'll have to go back into it to see what went wrong, and that's what we're going to do today. So I have the bell housing off already, just to get it out of the way. Now we'll go ahead and we'll tear into the transmission. So let me reposition the camera a little bit, and we'll get a better view and begin the tear down. Alright, one of the first things I did when I took this in is, just kind of put my nose up close to the bell housing and, pump area and smell the fluid. And, I mean, fluid smells brand new. It doesn't smell burnt at all. So whatever happened really quick. And the end result, I don't think, is a burn up of the 3.4 clutch. I think it's just simply a total loss of fluid pressure in that 3.4 circuit. So why that is what we're here to find out. So get the servo out of the way. So this transmission does have some upgrades to it. That vehicle is used in kind of a towing off-road situation, and customer frequently takes it off-road in the backcountry where he's located. Now, the reason why I didn't rebuild that last transmission initially is because he lives kind of far away from me, so I elected to build core out of my pile and just so he wouldn't have to make multiple trips, exchanged it with the core that you saw in the last video. And so that's kind of the story there. All right, so here's a servo cover, 4th clutch piston, getting unremarkable. As you can see, the fluid itself is fresh. I mean, he put new fluid in it. And then here's the rest of the servo. Got some, whatever this is. This almost looks like sealing ring material, but we'll take a closer look once we have the drum out. So there's no issues with 1st and 2nd gear. No issues at all. He didn't report anything unusual. It was just a loss of the 3/4 pack. Because all these electronics are brand new, when I go to reassemble this transmission, I'm just going to clean them up, make sure that they're functioning correctly, test them, and then put them back on. I mean, they have like literally 200 miles on them, so I want to make sure I preserve the harness. I mean, they're not super expensive, but why spend money when you don't have to? All right, the vehicle itself is, I believe, like a late 80s Toyota Land Cruiser. So the transfer case he's using requires a 2-wheel drive output shaft to be installed, and then he has to cut it to length so that it works with the transfer case and the adapter that he's running on that, on that vehicle. This one's stubborn. Deal with it later. All right, let's see, end play. Okay, I could barely feel it. I remember setting this end play at 20 thousandths of an inch. So I know the end play is good and there's no change there. So as always possible, I just simply cut one of the sealing rings on the insulation of the pump for the final time. I mean, it happens. It's not something that I've actually ever done before, but there's always a time for firsts. So when we go back together with this thing, I'm going to install, a whole new paper and rubber kit, new seals, new gaskets, and all that good stuff. Any parts that are damaged, obviously, will be replaced. We'll put all new clutches in here, and we'll look at the steel plates. If the steel plates are still good, then we'll reuse them. If not, we'll replace them too. This is basically going to be a complete overhaul all over again, but I'm going to just put a factory 4x4 shaft in here and sell it for use with a 4-wheel drive application. All right. Turn this way. Check that camera angle. So every transmission builder is going to have comebacks, unless they haven't been working in the industry for a while. Maybe they're brand new, but anyone that tells you that they have never had them, or their record is perfect, is lying to you, or they are God's gift to the industry. My comeback rate is very low because I go to great lengths to try to prevent it, because obviously it's costs me time and money, and not only that, reputation suffers with the customers. So I have all kind of things I do to make sure, both procedurally as well as from a quality check and quality control perspective, to make sure that never happens. But there's certain things that are beyond all builders' control, that will kind of lead to these scenarios. and get some of this fluid. So we took the converter back as well. Anytime this happens, you know, we always overhaul the transmission all over again just to make sure that everything is good to go. I don't just open it up, fix what's wrong, and then give it back to him and, you know, let him reuse the converter. I always replace the converter with a new one, and I always overhaul the unit again completely as needed. So I'm looking at this fluid. I'm seeing some kind of bronzish material that may be bushing wear, but it may be wear from something else. See if I could zoom in on it. And you can kind of see it floating around in there. And it's coming off the pan, or out of the pan I should say, and then into the trackway. So, you know, we'll see if you know, that becomes more pronounced as we move through the teardown, and if there's a source within the transmission for it. Alright, I'm going to zoom back out onto the transmission. Alright, so we do see some burnt clutch material in here. That definitely smells like burnt material, and you can see it. So you see a lot of matter here on the magnet. Now the question is, why did that happen? You know, what caused this? Alright, goes to the later model unit. His application requires the use of a shallow pan, so we have a shallow pan filter installed. Let that drain. I definitely see burnt clutch material. So shift kit was installed. It's Transgo orange box SK4L60E. And we installed an upgraded boost valve as well. No reason not to reuse that. I always use the Sonnax 4L60E LB1. Alright, gotta put that to the side. Get that out later once we have the air on. Looks like I have to change my battery in the impact. So again, all brand new electronics. Three-fourth failure is really only caused by some sort of issue with the hydraulic circuit. There's usually nothing in the valve body that's going to trigger you know, burn up of that 3/4 clutch pack, independent of everything else. Let me get a new battery. So I've already gone back together with that other unit you saw in that first autopsy video. So we did the same upgrade there. In fact, I put an improved clutch module in there. This one has just factory spec clutches, though it does have a 7 clutch 3/4 stack. The one that went out the door back to him has a an Alto high energy Kevlar clutch module. So 9 clutches in the 3/4 pack. Clearance was set to 40 thousandths. This pack I set the clearance to 45 thousandths. All right. Hands are very slippery, so kind of fumbling tools. I'm going to change out the battery real quick on the camera and then we'll resume. And broke that. So, looks like I'll be into it for a harness. And then this thing popped out, so I think no matter what, I was going to be replacing the harness. So, unfortunately, comebacks can get very costly for the builder if it's in fact the builder's fault. If it's something that occurred, you know, if the cause behind this or really any failure is the result of like a subsystem outside or external to the transmission failing, causing damage to the transmission, you know, I don't cover that kind of stuff under warranty. Likewise, I don't cover installation errors or situations where, you know, the vehicle's used and abused beyond the scope of what it was originally stated to be used for when the transmission was rebuilt. So, you know, like if somebody says they're, you know, they have a daily driver and then I build it to that level and then they start drag racing it and stuff breaks, then obviously I wouldn't cover that. There's all the check balls. Alright, so I'm going to test this valve body like I do all of them. I mean, I tested this initially on the vac test machine. It was fine. I'll test it again. You know, I don't see why anything would change, but you never know. Because one thing that can, I guess, you know, with the valve body cause 3/4 failure eventually is a very weak actuator feed limit valve, or, you know, where the AFL bore is worn. Now, if the wear is mild, a shift kit usually fixes that by the addition of an internal spring that goes inside the main AFL spring, and that causes line pressure to go up, you know, or I should say AFL pressure to go up and have more AFL pressure available to all of the solenoids. I mean, the AFL valve, actuator feed limit valve, is in essence a solenoid regulator valve. So other transmissions refer to those valves as such. GM refers to theirs as an actuator feed limit. For all intents and purposes, they're the same thing, just different terminology. Alright. I'm also going to ohm out all these solenoids. I mean, like I said, when you have 3/4 failure but everything else works, it's not likely that you're going to have an electrical issue, though it's possible. It's just not likely. Yeah, so here's how I drilled everything out. There's the other filter. All right. I get this on the other bench. Got a bunch of check balls there in the channel of the bench here, so we'll have to fish those out. brand new accumulator pistons in the 1-2 as well as the 3-4. You never want to reuse your accumulator pistons. And then here's the 3-4 accumulator return spring that comes in the Transgo kit. 3-4 check ball, or 3-4 accumulator check ball, I should say. Right in there, I don't know if you could see it, but you can see the Sonnax boost valve. Alright, I'm going to take the pump out. First we got to take off that O-ring. Otherwise your pump will never actually come off the shaft. I kind of want to be a little bit more deliberate here on this one. All right, we'll take a look at the pump in a few minutes, but the pump itself seems to be fine. I mean, there is no indications that there is line pressure issues in general. So we can look at the gasket. And I don't see any area, or I should say any feed port that's blown out or cut. So if that happens, then you obviously have impairment in whatever circuit that hole corresponds to. It's tough to diagnose that on teardown because most of the time the gasket rips anyway, but sometimes you can spot it, and at least that'll give you some idea as to what happened. Looks like the fan got caught up. All right, now let's go ahead and yank the two drums. The band looks brand new. Reverse input drum. Again, no signs of stress or slippage or anything like that on the band. Okay, looking at the drum, doesn't appear to have any kind of issues. Although, let's see what this is. This is dirt, or if this is a failure of some kind. If so, that's a crack right there, right here. Then that would explain our situation. All right, let's look at the ceiling rings. And they look intact. They look brand new. All right, I'm gonna fire up the air compressor, put some fluid here in the base, and then we'll go ahead and we'll do a pressure test on this drum to see if it's leaking real bad here at the shaft. I pressure tested this before it went out the door. No leaks were present, but that doesn't mean that it may have had an issue once it went back in. In other words, it was right on the edge of failing such a test, but it was not to the point where that would show up when we you know, did our fluid bubble test, if you will. All right, stand by. All right, so I'm going to put air here in the 2-3 feed, and we'll see what kind of, if anything, you know, bubbles or other signs of impairment within this drum that this test may reveal. All right, I don't see any bubbles at all. You don't need a lot of pressure for this, 50 to 60 psi at most. Okay, you use too much pressure, air is going to eventually escape the nozzle, and it'll, you know, kind of move the fluid around. You may get a false positive. The bleeder ball is working, so when you put air in it, you want to make sure that that bleeder ball is moving around in there. Okay, all right, so that's the 3/4 clutch pack. Now we'll do the forward. Forward's going to be right here. Okay, again, very healthy. The only hissing you were hearing was coming out of the nozzle because I didn't have a perfect seal there. But other than that, it was sealing very well. So I'm going to plug the forward feed with my finger so I can test the coast clutch. All right, see some bubbles forming. Let me stir up that fluid again. Go back to the 3/4. What I'm doing is I'm scrutinizing this area down here. I mean, if these are bubbles coming out of that area where it's press fit into the drum, what we're seeing is nowhere near enough to cause 3/4 clutch pack failure, at least not after only a couple hundred miles. So whatever the problem is, it's not the drum. One other thing that I have heard happen, I've not seen it myself yet, is either the ply or backing plate in the 3/4 breaking apart, and you know, obviously that would cause a no apply situation for the 3/4. So let me reposition the camera. We're going to turn this thing over, and we'll start looking at the 3/4 clutch pack to see if it's burnt up. If it is, then at least we have our direct cause. But what we need to further understand is the underlying driver, if that's the case, because so far the drum itself appears to be fine. All right, make sure that it's in the shot. Now, I don't put any load release springs back into these things unless we're doing something super crazy, a lot of horsepower, a lot of RPM, and we're already using high rate return springs, and clearance is below 40 thousandths. Actually, I generally stick to a guideline of 35 thousandths. Okay. So let's take a look. So, intact backing plate. First 3/4 clutch. First steel. Okay, we definitely have some wear here. Actually, there's not much wear though at all. It's just simply the lighting. I thought I had some wear, but as you can see, the Exity FDF stamp, I mean, it doesn't look like it's been compromised. And I'm smelling the frictions. They don't smell burnt to me. They do look a little bit stressed. Now these are 4L65E spec frictions, so they're 65 thousandths thick. In fact, let me get my calipers. probably a good way to measure wear. Okay, this one actually is 80 thousandths thick, so I have a mix of frictions in here. This is factory 4L60E. I'm just recollecting incorrectly there. Alright, these bottom 3 steels are choline steels. I had some in the drawers, so I just threw them in. Okay, this is a 4L65E spec friction. So it looks like I had a mix. And then we had an apply plate along with a 700R4 apply plate support. It's perfectly fine to use in a 4L60E. I mean, we're talking about the exact same type of drum. So I'm going to put everything back in and then we can just visually look at the clearance because I didn't really do that. I'm going to zoom in a little bit. Alright, all that air you're hearing is just my nozzle. I'm kind of in an awkward position. Alright, I'm not seeing anything that's super obvious here as to why this pack failed. I mean, technically it didn't fail. There's no overt signs of wear or no, kind of delamination of friction material coming off of, the steel, core, so to speak. Clearance is set at 45 thousandths, at least as measured on the bench. It tends to open up, so I mean, as I'm looking at it, I'm thinking I have probably 50 to 55 thousandths, which again is perfectly fine for a 7 clutch stack. So here's your backing or apply plate and apply plate support. 1, 2, 3, 4, 5, 6, and 7. I don't know how consequential this is, but it looks like there may have been something floating around in there, some kind of matter. Again, I'm not sure how critical that is to what happened here, but the main thing is I'm not seeing anything so far that is helping me better understand this failure. Okay, those frictions will not go back in, obviously. Alright, let's take a look at the forwards. I mean, he did not specify or mention any concern, moving forward or, your 1-2 shift. So the band looks fine. Forward clutch pack, my guess is going to be fine, but, we'll see. previous transmission obviously had smoked forward clutches, and you know, in that autopsy video we kind of saw and showed you exactly what happened there. Alright, again, want to make sure that the stuff isn't shot. Check the Viton seal. Viton seal doesn't want to come out. I didn't do this on the last video, I should have, but you always want to check that sealing surface, make sure it's okay. I mean, again, that's not going back in. A whole new paper and rubber kit will be installed, but just for purposes of, you know, trying to understand what happened, or if there's any other concerns, you want to check that stuff. All right, so here's our forward and our coast clutch. So, backing plate looks good. Frictions look brand new. These are Borg Warners. And I must have transferred the coast clutch backing plate to the front of the pack for some reason. Oh, this is actually the back side. So here's our wave plate. Steel plate. Friction. Steel. Friction. Steel. Friction. I did prep these steels prior to installation. You know, just took a wafer pad to them. They were generally speaking in good shape, but there was some spots that needed to be kind of touched up a little bit. And then here is our coast clutch. So here's our bottom steel. This is actually the side that faced down towards the piston. Friction, steel plate, friction, backing plate. So again, no issues with these particular frictions and these particular steels. They look in good shape. Brand new input sprag clutch was installed. I always install a new one-way clutch. Yeah, the sun gear looks fine, the hubs look fine. You know, nothing broken or fractured or whatever. The teeth are in good shape. I mean, like I said, that wouldn't really have anything to do with the 3.4. If this fails, then you have no movement whatsoever in drive or D3. You will only have movement. I'm sorry, you won't have movement in drive. You'll have movement in manual low 2 and D3 because you have your coast clutches come on and they will give you movement. But anything beyond that, you're going to be neutral in forward. If that's either broken or if somebody installs the sprag backwards. Alright, let me go get the snap ring out of here and then we'll take a look at all the pistons and stuff. Alright, snap ring is out. Our forward. And let's get the rest of it out. Alright, so let's take a look at the base of the drum and the interior. Okay, I want to get that O-ring out real quick at the base. See if that has anything to do with why this failed. It's not likely. This O-ring, when it fails, you'll have third gear starts. O-ring appears to be intact. Looks like we have some gouge marks here there on the sidewall. I'm not sure if they were there before. They may have been. That could have been snap ring, just, you know, me being clumsy with the snap ring, taking it out. But they're kind of all around the circumference of this drum. And to be honest, now that I'm thinking about it a little more carefully, I don't remember seeing them. So to what extent that contributed to anything, who knows? It's not real obvious to me. Like I said, sealing rings appear to be in good shape. So here's our third clutch piston, a brand new bonded piston. Again, I see a little bit of material here. I think this is sealing ring material off one of those turbine shaft sealing rings, but that is nowhere near enough material to kind of explain 3/4 failure or neutral condition in third gear. This feels fine to me, but you know, we won't know until I get all this stuff cleaned off. We'll take a much closer look once I have these parts cleaned and all dried off, no fluid and other whatnot on them. Alright, so all this stuff is going to get cleaned off. So far, unfortunately, I don't see anything, you know, any smoking gun anyway. You know, maybe there's something I haven't seen that, you know, you guys will catch and you'll say, hey, you missed that, or oh, did you check that, or did you see that? This is why it failed. I mean, you know, again, most of my attention is on what I'm doing here, but some of it is on the camera too, because these cameras consume batteries like nobody's business. And, you know, I get a half hour out of this, sometimes less, and I have to change a battery. So I don't want to be caught in a situation where I'm talking away here and I have no battery power and nothing's being recorded. And that has happened to me a few times. Reverse input. Brand new. So 4 frictions, 4 steels. And then this has absolutely nothing to do with the 3/4, so I'll disassemble and clean that later. All right, we'll take a look at the pump now. And again, the pump itself is not a suspect here, just simply because I don't know what could go wrong with the pump that would cause 3/4 failure, but allow everything else to function perfectly fine. He said that there is no other drivability symptoms associated with any other gear other than third gear. Bushing, looks like there's a little bit of wear. This is normal. Same with the front bushing, although it looks like there was some particulate matter may have passed through here in this front bushing. Okay, it looks like there's, you know, definitely some sort of scoring that's not usual. So I think there was some contaminants in his system still after, you know, and he replaced the trans cooler he replaced the cooling lines. Yeah, I don't believe he replaced the radiator. If I remember correctly, when asking him, he said that he flushed it, but he did not replace anything. But he was pretty thorough when it came to refreshing his system as a whole. And, you know, because he's wary of lubrication, you know, failures due to restrictions and contaminants being in the system, you know, as a result of the failure of the last transmission. Like here, he strongly suspected there was, you know, problems with circulation. So, all right, 13 vein pump, new rotor guides installed, new vanes. So I don't expect to see anything unusual in here. New bushing. Again, I'm seeing a little bit of scoring here on the bushing. There's definitely some matter floating around, circulating in the system that may have had some, you know, mild adverse effects on parts like bushings, but I don't see how that by itself could have caused the 3.4 to fail, or at least not function. I mean, the pack technically, there's no damage to it, so I don't want to say it failed. It was not functioning. And one thing I didn't have him do, and this is stupid on my part because I always tell people in forums if they think that there's a problem with their third gear, as I always tell people, you know, disconnect the large case connector on the side of the transmission, start it up and see if it'll move. And I didn't have him do that with this, and I should have, so that's on me. But that's one thing that if you suspect a 3.4 failure and you're actually experiencing a neutral in third gear, to rule anything else out, you know, you want to have, I should say, you want to do that test, because if you're moving forward when the case connector is unplugged and all of the electronic command and control has been bypassed, then you don't have a mechanical problem in third gear. You have some sort of command and control issue, so that's going to be either you know, computer, ECM, or possibly valve body, solenoids like the EPC maybe. So it could be that he has that issue. So what I'm going to do is I'm going to tell him, you know, after he fills his fluid up, because this literally just happened, he hasn't installed the new transmission yet, he's not going to for another couple weeks, you know, as of the filming of this video. So I'm going to tell him to run that test to make sure it moves forward, because if it doesn't, then it's going to be, you know, command and control issue, but I don't see how it would be associated with the transmission, since this is going to be a different transmission than that transmission. So that means that there might be an ECM problem. And again, I'm just spitballing here because I haven't seen anything obvious that would explain what had occurred. So pump rotor is in good shape. It would help if I had my finger not in the way. Slide is in good shape. Yeah, there you could maybe see it. There's the support O-ring in there. No concerns with this pump. I'm going to take apart the stator, but first we can look at the working surfaces. You can see some scoring here that obviously was not there when this went back in. We have scoring here on the perimeter where the slide operates. So more evidence of something circulating within the system, and no idea what it is. Probably just residual contaminants from, you know, the previous failure. That's my guess at this point. And while that could be detrimental, I don't see that being the cause of no 3.4. And of course this is going to fight me too. Yeah, it's coming. I mean, that was way sloppy. Way sloppy. Now we'll go ahead and kind of force it out. Alright, there it comes. Alright, looks like the one of the O-rings got cut a little bit. I mean, you can see pieces of it there. But again, that's not going to cause 3/4 failure. I mean, if anything, it'll cause forward failure before it causes 3/4 failure. Okay, springs are intact. Nothing remarkable there. For the 200 miles that he drove this thing, it did not have any problems with the converter clutch. You know, clutch worked as it should. All right. Journal surfaces look okay. Sealing rings look okay. I mean, these are reverse input, so again, no impact on any of the forward gears. All right, we so far have seen only some evidence of particulate matter circulating. Again, not enough, at least not from what I've seen. Now, maybe there was a whole bunch more, and all the evidence kind of disappeared when the pan was dropped, but I mean, I don't see any harm to the sealing rings, so even if there was matter in there, I don't see how that would have made the difference here in terms of causing this problem. All right, just pump out of the way. All right, I'm going to reposition the camera a little bit so I can, you know, get the rest of the gear train out of here. We'll look at that real quick, make sure that there's nothing missing or nothing awry, and then we'll wrap up at least this portion of the teardown. Then once I get everything cleaned off, I'll go ahead and we'll come back and do a much more thorough scrutiny of all the parts, you know, when they're clean. All right, if you watched the last video, this is kind of where the you know, front gear set would not willingly come out of the case. You know, we kind of had to beat the output shaft back so that we can withdraw, you know, the front planet set. This set has no issues. Okay, do our usual checks. Largely unremarkable. It's our bearing. Okay, new bushings here in the reaction shaft, a little bit of wear there on that rear bushing. Okay, this is a Sonnax Smart Shell. This will go back in. This bearing comes with the Smart Shell kit. My humble opinion, this is the best Sun Shell on the market for these transmissions. The TCI B Sun Shell, the couple that I have used are very similar to this in that they have a rollerized component, and they give you a bearing. It's machined for the bearing. Another good upgrade to do here is a Sonnax wide sun gear bushing. That's always a good idea for anything real high performance, especially high RPM. Low RPM, it's not as critical, but once you get upwards of 5,500, 6,000 RPMs, bushing stability for that sun gear starts to become a concern, and you want to mitigate the risk there by installing that wide bushing. All right, here's my anti-clunk spring. Alright, and if you haven't watched any of these videos, as far as placement of the ends, you always want the ends to, be on either side of that anti-clunk spring. You don't want them to overlap, especially on the side that's curved right here. This is the curved portion of the spring. If the snap ring overlaps that portion, there's a good chance that deflection as this thing's working will pop the snap ring out, and that would be bad. Your ability to go in reverse will cease to exist. Alright, center support. It's our top friction for our low reverse. Support itself. Again, recall in the last autopsy, about 30 thousandths or so is quote-unquote machined off of the apply surface here, and so that support had to be sent to the scrapyard. This particular one looks fine. Like this one is being stubborn. Look at those frictions in a second. And so we got a steel plate and a wave plate. I'm not sure what's holding this thing in. Got some check balls coming out. If you watched teardowns before these units, this thing normally just comes out. It looks like there might have been some particulate matter holding it back. Bearing, feels fine. That is the rear case to output thrust, and then here is the rear planets bearing to the ring gear. Feels fine, looks fine. The ring gear itself, along with the journal surface. Again, nothing real obvious in terms of damage or scoring or whatever. Splines look okay. And we'll look at the rear planet itself. This one's got a little bit of vertical play, more so than I recall when I put it in there. So all right, anti-clunk spring or anti-rattle spring. And here's a rear case bushing. Definitely look like there's some particulate matter, some detritus floating around in there. Oh, you know what it was? I never took out the linkage. It was the linkage holding it back. That's what it was. Duh. Duh. You guys probably figured that out already. And here I am trying to figure out what the hell's going on. Probably take the linkage out. $13mm here and then 15mm nut. Yep, this stuff has to come out too. All right, and now we have that sorted. So here's our low reverse cushion plate. It's our bottom steel, bottom friction, steel, friction, steel friction, all look brand new. So that burnt clutch material, as far as where that may have came from, it could have come from the 3.4, but I'm thinking that might have actually been residual still in the system. Like I said, the only thing that I don't believe he replaced was the transmission cooler, you know, the internal cooler in his radiator. Everything else, the external cooler, the lines themselves, I mean, he actually replaced them. He didn't just flush them, he replaced them. So, you know, kind of at a loss to explain what went on here and why he had no third gear, why it was doing what it was doing. Had the right clearance. I mean, there was no issues there. I don't know. Kind of a mystery still. So let me get all this stuff cleaned off, and then we'll go ahead and come back and we will scrutinize the relevant parts that, you know, all kind of pertain to the 3.4 clutch and associated apply circuit in a lot more detail, and be able to see if there's anything that is escaping our eyes, you know, with everything all dirty like this, but will be more obvious when it's cleaned off. So let me go ahead and do that, then we'll come back and, you know, we'll go through that process and then we'll wrap. All right, we finally have everything cleaned up, including the frictions, the steels, and the 3.4 pack, along with the pressure and backing plates, the forward piston housing, the 3.4 ply ring, 3.4 return spring, couple bearings, the pump cover stator, the third clutch piston, and the forward drum. And I also have the spacer plate and gaskets. So just taking a look at the clutches themselves, there is some signs of wear to them. They are not in brand new condition. I dried them off with a shop towel. And while they're not completely burnt, they do have some wear, and you know, there's some glazing. You know, they're not like in new condition. I mean, this is what you would expect to see in a transmission that has, you know, well over 100,000 miles on it, not what you would expect out of something that was just put on the road. So there's clearly a line pressure issue within this clutch, and that's really what we have to determine the cause of. The frictions didn't get smoked. There was no reports of actual slippage. It was just, it was working, then there was flaring, and then there was nothing. You know, just a neutral in third condition. So these are two different brands of frictions I have here. There's Exity, and then there is Borg-Warner. So a couple of them are 4L65E spec clutches, and I think the rest are the regular 4L60E spec. So 4L60E spec for 3.4 is 80 thousandths thick. on the frictions, and the 65 is 65 thousandths thick. So like I said, I measured clearance. I mean, you can see the difference. You know, here's one brand, here's another. I measured the clearance before I went out the door to be 45 thousandths. So probably opened up to about 10 thousandths greater. So 55 thousandths. Again, for a 7 clutch stack, that is more than fine. You should not have any issues, especially in a largely stock application in terms of RPM. This thing did not see any kind of high RPMs at all. Alright, so let's take a look at the forward piston housing and the 3/4. And the reason I say that is because the 3/4 clutch seals on the inner diameter against the piston housing here. So we want to take a look here for any unusual wear, any grooves, any excessive scoring, or anything that would lead you to believe that pressure is leaking at that junction. Alright, likewise, we want to really scrutinize the sealing surfaces on the lip seals of the piston itself. And these feel supple, they feel soft. There's nothing here that would lead me to believe that this was the source of the problem. I mean, these bonded pistons are brand new. They have a grand total of 200 miles or so on them. Okay, you shake this housing and you see the ball is moving, so there was no issues there. Forward clutch looked immaculate. Okay, return spring assembly. I mean, again, no problems. You know, what could have been happening is that they were glazing. If the clearance was less than 30 thou, I would say that could be part of the problem. Like, not necessarily centrifugal apply, but dragging and causing the clutches to rapidly wear and degrade. You know, when the third, 3/4 pack is not on. I mean, I've seen that before from time to time. But it's not common if the 3/4 pack is set up correctly. And like I said, you know, I mean, you can certainly argue with me, but I don't believe I made any errors in setting up this pack. Alright, here's your steels. So we have 3 normal steels and 3 Colleen steels. So there is some sign of, again, particulate matter passage through this clutch. You know, we see it pretty much everywhere in the transmission, but there's no signs of slippage, and that's the main takeaway here. No signs of slip marks anywhere, which usually you would have slippage in the 3/4 clutch if you had, you know, kind of a compromised 3/4 circuit where it was bleeding off pressure, unless the failure was so immediate that there was no opportunity for the clutch to slip. So just looking at the apply ring for the 3/4, you know, checking it over for any obvious signs of damage. I mean, there's none. You want to check this area in here. Okay. I mean, you know, nothing remarkable. Nothing that would jump out at me and say, yep, that's why this thing failed. It failed because of this, or failed because that broke, or that was excessively worn, or scored up so far anyway. Alright, we have the stator pump cover assembly, and you always want to check in the bore. Okay, you want to take a finger and you want to feel in there to see if there are any grooves cut into the inner diameter of the stator bore by the sealing rings. I hardly ever see this in anything up through 06. For whatever reason, and maybe it was just a rash of drums that were kind of created wrong, or I'm sorry, well actually, yeah, drums, where the groove itself would pinch on the seal, and it would not allow the seal to spin freely. Like, see how these seals, or sealing rings rather, are all spinning nice and free? They're not getting hung up in the groove. I occasionally see late model units where one or more of these seals is pinched because the groove itself's too tight, and it's not immediately clear how it got that way. It was probably manufactured that way, you know, a defect. But what it would do is it would cause the sealing rings to cut grooves into the inner diameter of the stator bore, and then that would cause clutch failure depending on which sealing ring or sealing rings were affected. So I've seen a lot of 3.4s and late model 4L60Es burn up for that reason. Seen some forward clutches burnt, again, for the same reason. It's just, you know, I guess a consequence of either manufacturing or something else going on that caused the problem. Alright, here is the apply plate. Again, I mean, it's, you know, I had to do some prep work on it, but I could see there is a lot of scratches here on the surface, which again, I would have never put this in if it looked like this. It did not leave here like that. This side, I think, is actually the side facing the apply plate support. This is the side that faced the frictions. I think, I don't know, I'll have to go back and check. I could be wrong, but either way, that one is not going to be reused unless it gets put through a lot of prep work. Here is the backing plate. This is the side that faced out. So here's the side that faced the frictions. It's got a little bit of pitting, you know, a little bit of imperfections. You can see, you can almost, I'm going to run my finger across, so you can almost see that it's slightly warped. Okay. I don't know that this would have been the sole cause of the problem. We got a kind of a scoring line here going vertically. So some evidence that matter definitely passed through there, some metal or something that was in the system. Alright, here's the forward drum. Nothing readily obvious that I could see here just looking down into the drum like so. You know, signs of lubrication failures, or, you know, nothing that jumps out at me that says, hey, you know, take a closer look at that. We have this area here, see if I can get it to focus, here by this little orifice, and I'm not sure exactly what that is, but from what I could tell, I don't think that this is cut through and through to where it was bleeding pressure, but I could be wrong. I mean, there's definitely some staining there, so that could be the source of our problem. Maybe this orifice itself is leaking, and I don't think I had the fluid all the way up to where, when I was doing the pressure test, this was completely submerged. So it could be I'll have to reassemble this drum. You know, I'll use all the old stuff just for the purposes of doing so, and then fill this with fluid and see if anything unusual is coming out of here, like a whole ton of bubbles maybe below this orifice that would indicate that there's a crack in the drum where you see this discoloration there. And this is what I'm talking about right here. So, you know, maybe some more investigative work that would need to be done. Now, for the purposes of, you know, warranty, I haven't seen any kind of incontrovertible evidence that would lead me to believe that there is an off-board, you know, driven cause behind what we're seeing here, you know, behind this failure. So, I don't think we're going to be in a situation where I'm going to ask the customer to reimburse me for all the costs. One other thing that I'll bring forward and we could take a look at is the spacer plate. So, like I said, this trans had the shift kit in it. It's Transgo kit, and then I had a repair here for the 1-2 check ball. Nothing unusual about the hole sizes. I did drill the TCC and the AFL balance out a little bit, not as much as Transgo recommends. That would not cause the problem that we're seeing here. I mean, if we had a problem, you know, as far as leakage in the AFL circuit, then we would have seen that everywhere in the trans. I mean, all the clutches would have been smoked. This is going to be band release 93 thou. This is going to be a 2-3 feed. This is 93 thousandths. Low reverse 93 thousandths. The 3-4 feed is 93 thousandths. The 1-2 feed I drilled to 76 thousandths with the vet servo. You know, we installed a custom low stall converter in this thing because it was used for towing, hauling, and off-road. So nothing unusual about the way we mechanically calibrated our shifts. You know, nothing overly aggressive or unconventional, unorthodox. I mean, you know, plate itself's unremarkable. It doesn't appear to be warped or flattened or anything. One thing we can do is scrutinize the gaskets themselves. So we have, this is the valve body gasket. So this is going to face the valve body. And here is our 2-3 feed. And we don't see any kind of ripping or tearing of the gasket in this area, at least on the valve body side. And we look at the same thing on the case side. Okay, so here is the 2-3 feed. So as you can see, there's no rips or tears or anything like that that could potentially have created a cross leak, and a cross leak, you know, between the valve body, the spacer plate, the gaskets, and the case at the 3-4 location or in that vicinity would undoubtedly cause failure, but it would usually result in slippage, and there was no reports of slipping, you know, associated with this failure. Whatever it was quick. It happened within really one drive cycle, technically 2, but you know, he traveled less than, I think he traveled less than 5 miles between when he first encountered the symptom, or you know, first felt the flare, and when he pulled it off the road. So whatever happened, it happened quick. Now, one other possibility I considered was that I accidentally assembled this transmission with a late 2006 drum that has the placement of the sealing rings and feed port locations that are consistent with an input shaft or the reluctor gear for the ISS, or input speed sensor. There was a very small number of drums, you know, or drum shaft assemblies manufactured in late 2006 for that model year that had the placement of the sealing ring grooves and feed ports just like you see here on the shaft with the reluctor cast into it, but they did not have the reluctor itself cast. Okay, because of the placement and the offset relative to the pre-ISS input shafts, GM installed pumps that were intended for use with an input speed sensor, but then instead of having the speed sensor installed, they had a little plug in place with an O-ring. So for, you know, I don't know how many or what percentage of all, you know, trucks and SUVs manufactured that year that had the ISS installed, you know, what percentage of those actually came without the ISS and without the, you know, programming and transmission control logic that did not have it, that had these particular input drum assemblies. So if I had done that, let's just say I have, you know, a pre-ISS pump and a post-ISS input drum with the shaft without the reluctor gear in it, I would have all kind of problems with all of my clutch circuits, not just the 3-4, because there is fairly significant offset. And I'll flash a picture on the screen to kind of show, you know, them just at eye level. But I mean, you could readily see if, you know, I guess maybe, I don't know if it's going to translate through video, but there's a clear difference in the height between the coast clutch feed here and the coast clutch feed here. All right, now this table's kind of undulated, so like I said, that's why I think the picture is going to be a better representation. At least visually, it'll be a lot easier to tell. But point I'm making here is I want to make sure I investigate all possibilities and, you know, all potential causes, because as of right now, I still do not have a smoking gun for why this 3-4 pack failed. There's clearly stress, you know, indicators on the frictions, but there's no slippage on the steels. And, you know, per the customer's account, whatever happened here happened all of a sudden. And so I've not had something quite like this before. So I guess it's 2 transmissions in a row where I'm seeing something that I haven't seen before, despite building over 2,000 4L60Es in my lifetime. That doesn't mean really anything. I mean, 2,000 it's not a huge amount. There's builders out there that have done 2,000, like I said, in probably a couple years worth of building, maybe less, and they've seen a lot more than I have. But for what it's worth, this is new to me, where I cannot quickly and confidently identify the direct cause behind a given failure in a transmission after cleaning and inspecting. Now, the investigation is going to continue. You know, I'm going to at least give it. I'm going to give myself probably another week to just, do some more research, maybe talk to some other builders that I know personally here in town and see if they've, had a similar failure, and maybe I can learn something, or, something they can, give me some insight to. But for right now, I don't see anything that is obvious to me. Now, if you see something that thus far in the presentation that sticks out for you or raises a red flag, please put it in the comments. I don't pretend to be the end-all, know-all, and I'm learning pretty much every day I work on transmissions. Chances are I'm learning something new. So this is brand new to me in terms of the specific failure and the speed or velocity at which it happened, and what we're seeing here in the evidence, on the different parts, and what we're not seeing, right? Like, not just an obvious cause. I mean, we could look at the drum. Sometimes you'll have 3/4 failure when you have a crack in the drum, and that will cause, problems down here, because the bore in here for the 3/4 piston will no longer be perfectly round, so you'll have pressure bleed off and loss. Okay, even though the crack may happen up here, it'll still affect the rest of the integrity of the drum. So I don't, when I clean this off, I eyeballed it closely. I don't see anything structurally with this drum that, where I can point to and say, yeah, that's what happened. Needless to say, when I go back with this transmission, I'm not going to reuse this drum. And that's just simply because the failure is going to be confined to either this drum or the valve body, or the pump. And I'm probably going to swap out the pump too. I mean, I have, a shelf full of, pump assemblies, input drums, so it's no big deal for me to do that. Just out of an abundance of caution, I don't want to repeat a history. So anything associated with the 3/4 pack, I'm going to replace. So it'll get, obviously new bonded pistons, new frictions. I'm going to put a steel module, at least in the 3/4. The rest of the steels are fine. But whatever is connected to the 3/4 hydraulic apply circuit is going to be either reconditioned or replaced. So the rest of the transmission will get what's called an overhaul kit. I'm going to put a band in it. I'm going to replace all the bushings, and then the wiring harness, and seals, gaskets, the usual kind of consumable stuff. But yeah, it'll go back on the road. It'll be a good transmission when I'm done with it. Reinstall the shift kit, reinstall the same spacer plate, and all that good stuff. But I don't. If you have this problem or any kind of problem, you're not sure why, or the direct cause of the problem or the breakdown is not readily apparent, the default is to just replace stuff. At least that's the way I approach the problem. Your thought process may be a little different, and that's certainly fine. There's more than one way to skin the cat. So anyway, unfortunately, I couldn't, give a more satisfactory conclusion here, which sucks for me because I still don't know what the hell I'm dealing with, But either way, thus far in the investigation, I don't see any incontrovertible evidence to suggest that something else happened, outside the transmission that would cause this failure. It could be some latent defect in the drum that I just cannot see, something in the shaft. I mean, anything's possible. You never know. That's why I'm replacing it, just to be on the safe side. But suffice to say, for a split second, I thought I may have made like a major goof installing a late 06 input drum with an, say an 05 in back pump. Technically, it's an 03 in back pump, to where we had completely misaligned feed ports, because that's what would have happened, but that's not the case here. Anyway, I hope this was at very minimum entertaining, maybe a little educational, I don't know. But as always, I greatly appreciate your viewership. Thank you for taking the time out of your day to watch this. And if there's anything else you'd like me to film or discuss in more detail, the 4L60E, let me know. I'm always going to be making videos. I know I have a couple videos coming up on this transmission. We're going to be showing you how to do, band clearance and adjust for servo travel, measure, the inboard travel, the servo to get the band clearance correct, and we'll kind of show you what wrong looks like and then what correct looks like after we do our iterative adjustments there. And then I'm also going to do a video on valve body testing, comprehensive valve body and pump cover testing via the Sonnax vac test machine, so you can see what that process looks like. And we'll do a follow-up video showing you actually remanufacturing one of these valve bodies. And we'll do the same thing with the 4L80s too. So anyway, thanks again. Enjoy the rest of your day or evening, and we'll catch you on the next video.